All right, this is the video review for the square root functions unit that we did. It was a short unit. It has a lot of graphing, and then it has a few other things that involve algebra. So the approach for this video is going to be just getting you through the graphing portions of the stuff. All right, when we graph, there's four letters that we had used when we wrote equations. There was an A value, a B value, and then sometimes we call this C or H, and then there's also the K value that we used. And the two examples that I'm doing here on the review, they're intended to give you a variety of what stuff could happen. It's not going to cover everything, but a good variety without overwhelming you and having too many things within one problem. In addition, we're going to state the domain and range using both set builder and interval notation. I'll just do one of each so that you can see what they look like. And you do need to know how to do those on the test. Okay, so the very beginning thing with these, obviously you should be aware of what the parent function looks like, which is just one side of quadratic. It has its same pattern to it, and there is going to be a well-defined endpoint, and then it might bend this direction, it might go that way, it could go this way, and it could go that way. Okay, and what I'm going to have you do when you graph is really focus on the endpoint to figure out where that goes. Because if we can find that location first, everything else as far as like stretching and flipping is going to be based off of that. Okay, so you're going to see this graph that I've already got these dashed lines on it. I got a vertical and horizontal there. The point at which they meet is going to be the endpoint for the graph. And now, how I came up with that is looking at any of the adding or subtracting values they got here. The value that is right after the x, if there is one that says adding and subtracting, that's going to give you the x value for, I already realized here that I graphed this wrong, so not too bad that you get to see something incorrect right away. But I'm not going to restart the video just over that. So, okay. That number is going to show up as the opposite when you look at it as an endpoint. If you had a value that was on the end of it, that would be exactly as it appears. And since we don't have anything, that one's going to be a 0. Okay, so that is going to put our endpoint actually over here. And it's good to actually see that I had it as a +1 because that's what you naturally think, but it was in the other direction. Okay, so as of now, if that was the only thing that was happening, then the graph would just kind of go this direction. And now what I like to do is always draw the parent function, or to graph a few of the points of the parent function, then based off of what I have for A's and B's, think about how it flips and so on. Anyhow, we have the endpoint here. The next point for the parent function would be over 1, up 1. Then after that, the next one would be over 3 and up 1. Then after that, it would be over 5 and up 1. So you'd have another point that's over here off to the side. Okay, now the thing that we have in this graph is that there's the negative sitting in the front part here. It's in the radical, but it's in front of the x. That is going to tell us that we're going to get a horizontal flip. So this graph is actually going to point that direction. But it doesn't flip around the y-axis. It's actually going to flip around wherever your endpoint was. So remember how I apply to the points going this way. I'm just going to do the exact opposite within that direction. I won't have room for that last point, but as long as you get a couple of them and those points are very obvious to us, we'll be able to tell that you did the stretching, compressing, and flipping all that stuff correctly. And that's it for that graph. As far as the domain and the range, let's do this as set builder. Those aren't too nice. Set builder is going to have these braces at the beginning of them, and then afterwards you're going to state the letter that goes with the domain, which is the x. You're going to draw a bar. You read that as such that. So this is the set of x's such that. Then you give an inequality that goes along with that x. Okay, so for all of our x values, they go to the left forever, so they're just anything that's going to be less than that -1. And you just write that, close your braces, and you're done. Okay, the y's for the domain, the range, it's going to work out basically the same thing. These are going to be all values that are greater than 0. And that's it. That's set builder notation. All right, our other graph, one thing I went ahead and started with here, assuming that I did it correctly, was I acknowledged that the 1/2 exponent is exactly the same thing, the radical, so you might as well rewrite it and just look at it that way. The endpoint that we're going to get from this is going to be at a -2 and a +4, which you can see on this one I did graph that correctly. So it starts here. Other things that we have to look at is just this. We have an A value. And by the way, we're not going to try and mix B values with A values because that just gets really messy. So now that we're looking at an A value, it's definitely going to reflect it vertical. It's also going to stretch it by a value of 3 vertical. So the parent function would have been these points. It would go on over 1 up 1, over 1 up, or over 3 up 1, and then we can get this one over 5 up 1. That's the parent function shape. But now that we're vertically flipping this guy, that point, so all these are going to stay like lined up where they are. The horizontal is not going to change. But instead of that point being 1 above that line that I've drawn, it's actually going to be 3 units below. And if this point is 2 above, it's actually going to be 2 times 3, which is 6 down. So you got 3, then you got another 6. And that guy's at 3, so that's actually going to give you 9. So you get a 3, and then another 3. And that is that right? You'll notice that I missed that point a little bit when I drew it, but as long as you guys give us pretty solid coordinates to work with, we'll be fine. And you're not going to need that many of them either. If you just have a couple of them so I can still see that stretch, that'll be all right for the test. Okay, interval notation for this. You're going to have one side that is bounded, or the other could be the lower or the upper. For the x's, we're going to be bounded at that line, which is at -2, and then it's going to go on forever to the right. So you do brackets where it's bounded, and you have infinity in the other direction. The range, these are always tricky. You're measuring from the bottom up. You're unbounded at the bottom, so that's going to give you -infinity, and then it caps off at the 4. So you have a bracket there, and make sure that you get your brackets in parentheses correct for this. All right, the next question, what it is, gave you an outline of an equation, and I just want you to be able to describe some things about it, like the domain, the range, and so on. Remember that that's just the same thing as the square root symbol, so don't pay too much attention to the 1/2. If anything, it's really just a distractor, to see if you really know your stuff. All right, first couple of blanks will be square root, which I abbreviated here. The function f is going to be a square root, and that's coming from this being that radical sort of thing. So we have a square root function. The domain and the range are always going to be bounded. So what I'm looking for here is some sort of an inequality that I could write. You could use interval notation. I'll just use inequalities here. Okay, so thinking endpoint first, this is going to go to the right 4, then it's going to go down 7. Go to the right 4 and down 7. Just remember that. We're going to the right 4. Actually, I'll write them down here. They go to the right 4 and then down 7. The graph doesn't have any flipping because you don't have any negative here or there, so it's still going to move in this direction. Now, we're not actually needing to graph it, so don't worry about plotting too many points here. As far as the domain, we learned that x is greater than or equal to 4. It starts there and then goes that way forever. The range is going to be anything greater than or equal to -7. Starts there and then it moves up. It is vertically compressed. It's compressed by this number that's here, being that that's less than 1. It is going to shrink it, so it's vertically compressed by 2/3. All right, now the reason that I'm having you do a problem like that is because on the test, you're going to get questions like 4. You need a couple of these, but 3, I'm presenting it almost like in a backwards way, because if you can do things backwards and you can do them 4, then there's a better chance that you can continuously do them what I'm calling a forward direction here. Okay, so if I give you the description, I want to be able to also write an equation that fits it. Okay, so here's my description. It's going to have a domain, so square root function. It's going to have a domain greater than 6. It's going to have a range greater than 1. So what I did is I made sure that I drew some lines that intersect at 6, 1 at that coordinate, which is, in my little image, will be right there. The domain is going to be bigger than 6, so we're going to the right, and the range is greater than 1. So we're looking for a picture that goes roughly in that direction. Okay, now things that we know for sure within the equation. We don't have our a value figured out yet, We don't know if there's a b value, but we are going to have an x minus 6 because it's out to the right, and you're going to have a plus 1. Now, I'd also said before that we're not going to mix a's and b's, so we really want to just try and figure out how I use this coordinate, the 10, 3, to figure out what's really happened in the case. So now remember that our pattern, and this isn't a great sketch of it, okay, so don't pay too much of it. In fact, let me erase it so you're not staring too much at that. The pattern for the parent function is go over 1, up 1, then go over 1, up 3, then go over 5, up 1. So I got this 5, this 3, and this 1 space, and everything is increasing by 1. Now to get to 10, 3, from where we're at, which is at 6, 1, that means I have to go over 4 units, and notice that if I add 1 and 3, I'm going to get to 4, and then I have to go up. To get to the 3, I'm going to have to go up 2 units, because I'm already at 1. Okay, so I have to go over 4 and up 2. Let me erase that because it's sort of in the way. And when you compare it to the parent function, that actually turns out to be perfect. Over 4 and up 2 to grab that point. Okay, so what we're kind of left to assume here, and it's a little bit of an assumption, is that we actually don't have any vertical stretching or compressing because that point falls nicely there. That doesn't mean that you couldn't have both of them. It doesn't mean that you couldn't have a different point that I've really manipulated to get to that spot. But if I'm not going to mix A's and B's, then it's a strong belief that we're not actually stretching or compressing anything here. Now for the test, I'll make sure that all those things are mentioned, that if we don't have compressing, I will tell you this does not have any compressing. Just focus on these other two things. Okay. All right, 5. We're going to look at inverses for this. We have a quadratic function. I called it Q, so it would stand out as a quadratic. And I want to create the equation, not so much the graph. I really want the equation. The equation will be the inverse of the quadratic. And the easiest approach to do this, if it's in the right form, which this is in vertex form here, is just to take that equation and to switch your inputs and your outputs, and then solve it. So I rewrote this same guy. I just rewrote it with a y value here. I'm going to switch them, and then I'm going to work backwards and solve. So I'm going to multiply x by 4, which gets me to 4x. Most of this you can do if you just think through it. You don't really have to even write it. You're then going to square root, and then you're going to add on the 3. Let's draw a line here. Okay, when you add on the 3, we could go ahead and just rewrite everything at this point. You're going to have the inverse of the Q function is equal to the square root of 4x plus 3. You're going to add that 3 on, and then everything just kind of moves around, and that's your answer there. You could pull a 2 out of the radical, but this will be okay. There's lots of cases where the numbers aren't going to be perfect squares. So if you just leave it like that, that's fine, and we'll let it be. Oh, one other thing about it. I was going to make sure I pay attention to this. The quadratic itself isn't a one-to-one function. It's got two sides of it. Right? It's got, in this case, it opens up. It's fairly wide and opens up. It's got two sides of it, and if you were to try and reflect this diagonal, you're going to get a picture that looks like that. And they may overlap or whatever, but you get a picture that is not a function. So we're always restricting the domain to just one side or the other. This says that we're restricting it to be greater than 3, and notice that the 3 value would have been the x for the vertex. So I know it's not on the grid, and I could have probably used that, but the vertex is going to be at a 3. I believe it's still sitting on the x-axis because you don't have any shifting up and down, but to be at a 3, and we're keeping this side. We're going to get rid of that side. And here's the rule and how you need to know this and why we're applying it. For a quadratic, if you were going to keep the right side, which is what we're doing, then you're keeping the top of the square root. If you're going to keep the left, you're keeping the bottom. So what that means is when you get to this answer here, you need to choose whether it is positive or negative. And since we're doing the right side, it's going to be positive, so this answer is great. If I simply had that switched less than or equal to 3, and please watch out for it, but if I have that switched as less than or equal to 3, this will become a negative. It does not change that, but it will change this to being a negative in the end. All right, for this video, one more question. The other direction. You have the square root function. Notice it's positive here. That means it's a top side, so we're going to be looking for a right side inverse quadratic. We're going to do the whole sort of switcheroo. Okay, we got that. Oh, I already set this up to the side because there's something important we needed to know. Don't worry about that then. If you have a b value and some sort of adding or subtracting, which we either call c or h, you do need to factor that. Okay, so I already switched the x and the y together, which is one of the steps. But I need to also factor out the 2, because it's important we see that as a -4, not as a -8. Okay, now solving for the y value, we are going to square the x, which will get us to 2 times that stuff. You'll divide by 2. I probably suggest you just make that a fraction. Just put a 1/2 in front, and then you will add on the 4. And that, of course, would be equal to y, which means that this is the inverse of r. So that's the function. So most of that is the answer. But in addition, we need to choose a domain. Oh, we want a range too. I'm going to state that stuff. All right, the domain, let's see, that's a topside function. That's a topside function, so we're going to be keeping the right of this. This does not have any horizontal shifting going in. It's just a vertical shift up of 5. So that means that x is going to be greater than or equal to 0. It is centered around the y-axis. For the range, this graph has been elevated by 4. Okay, so roughly it looks like this. And that's a 4 right there. So that's really what the graph looks like here. It's been elevated by that amount. And that will place us at greater than or equal to 4. Okay, one other thing about it though, when I draw this, you might notice that the picture of the quadratic doesn't fit like what's going on with the domain. But since the square root function was a positive, that was really only the top of the square root, which means that we're only looking at that side, because we're only reflecting. This is the square root right here. Okay, and when it reflects over, you only get part of it, so that's going to bound it at a 0. All right, that should conclude everything that has to do with the graphing parts.